First question, it is integral of e to the power of 2 log x plus 1. By using a property of logarithms, it can be written as e to the power of log of x plus 1 whole square. Remember, e to the power of log a is a, so using that property it is x plus 1 whole square. So remember this very important property, e to the power of log a is a. So using that property, e to the power of log of x plus 1 whole square is x plus 1 whole square. Now the integral of x plus 1 whole square is x plus 1 whole cube by 3 plus c. It is option 1. So option 1 is the correct answer. Next, we move on to the second question. It is integral of cosecant square x into secant square x. It can be written as 1 by sine square into cos square. Cosecant square x is 1 by sine square x and secant square x is 1 by cos square x. And 1 can be written as sine square x plus cos square x. Now split the LCM. It is sine square x divided by sine square x cos square x plus cos square x divided by sine square x cos square x. Now cancel sine square and cos square here. So you get 1 by cos square. 1 by cos square is secant square x plus 1 by sine square is cosecant square x. For secant square x, the integral is tan x. For cosecant square, it is minus cot x plus c. So it is option number 2. So the correct answer is option 2. Question number 3. We have to evaluate the integral root of 1 plus sin x by 4. So in this problem, we use the formula for sin theta. Sin theta is 2 sin theta by 2 into cos theta by 2. So this is the formula for sin x by 4. We are using this formula. Sin theta equal to 2 sin theta by 2 cos theta by 2. So remember this formula. Sin theta is 2 sin theta by 2 cos theta by 2. Here theta is x by 4. Substitute x by 4 here, you get x by 8. Here also you get x by 8. Therefore sin x by 4 can be written as 2 sin x by 8 into cos x by 8. Now replace this 1 by sin square x by 8 plus cos square x by 8. Now this is a square plus b square plus 2ab. A square plus b square plus 2ab is a plus b whole square. So it is sin x by 8 plus cos x by 8 whole square. And it is the integral of sin x by 8 plus cos x by 8. Now it's very easy. For sin, the integral is minus cos. Of course, we have to divide it by the coefficient of x. Coefficient of x is 1 by 8. For cos 1 by 8, it is sin x by 8 divided by 1 by 8. The integral of cos x by 8 is sin x by 8 divided by 1 by 8, and it is minus 8 cos x by 8 plus 8 sin x by 8 plus c. So this is the answer. It is option number 3. So option 3 is the correct answer. Minus 8 cos x by 8 plus 8 sin x by 8 plus c. Now we move on to question number 4. In question number 4, integral of, this is given to be k by x plus 1 by a tan inverse x by a plus c. We have to determine the value of k. Now consider this integral, 2x square plus a square divided by x square into x square plus a square. We can write 2x square plus a square as x square plus a square plus x square. X square plus x square is 2x square. So we have written 2x square as x square plus x square divided by x square times x square plus a square. Now this can be written as x square plus a square divided by x square times x square plus a square plus x square divided by x square times x square plus a square. And it is integral of 1 by x square plus 1 by x square plus a square. For 1 by x square, the integral is minus 1 by x. For 1 by x square plus a square, it is 1 by a tan inverse x by a plus c. Now compare with this answer with the given answer. Given answer is k by x. So in place of k, we have minus 1. So by comparing, we get k equal to minus 1. It is option. Now question number 5. Here integral of x to the power of 49 tan inverse x power 50 divided by 1 plus x to the power of 100 given to be k times tan inverse of x to the power of 50 whole square plus c. And we have to determine the value of k. We have to use substitution here. So we use the substitution t equal to tan inverse x power 50. Now differentiating, we get 1 by 1 plus x to the power of 50 whole square and 50 times x to the power of 49. And therefore dt by 50 is equal to x to the power of 49 dx by 1 plus x to the power of 100. Now consider this integral. It is integral of tan inverse x to the power of 50 into x to the power of 49 by 1 plus x to the power of 100. And this is same as we have taken this as t, therefore integral of t, and this whole thing is dt by 50. Now integral of t is t square by 2, so therefore t square by 2 plus 100. Now substitute the value of t. The value of t is tan inverse x power 50. So you get tan inverse x to the power of 50 whole square by 100 plus c. Now comparing, we get k equal to 1 by 100. Therefore k is 1 by 100, which is option 3. The first question is integral 0 to pi e to the power of cos x plus e to the power of cos x plus e to the power of minus cos x. Let us assume that this integral is equal to I. So 0 to pi e to the power of cos x divided by e to the power of cos x plus e to the power of minus cos x. Now using a property of different integrals, we can replace x by 0 plus pi minus x, which is same as pi minus x. So we replace x by pi minus x. That does not alter the value of the integral. So it follows from one of the properties of different integrals. So 0 to pi e to the power of cos of pi minus x divided by e to the power of cos of pi minus x plus e to the power of minus of cos of pi minus x. Now cos of pi minus x is minus cos x. So remember, cos of pi minus x is minus cos x. So this is e to the power of minus cos x, e to the power of minus cos x. Cos of pi minus x is minus cos x, minus minus is plus cos x. Now we add 1 and 2. Now add 1 and 2. Adding 1 and 2, we get I plus I equal to 0 to pi e to the power of cos x divided by e to the power of cos x plus e to the power of minus cos x. Plus this is e to the power of minus cos x divided by e to the power of minus cos x plus e to the power of cos x. Then it is 2i. 2i is equal to 0 to pi e to the power of cos x plus e to the power of minus cos x divided by e to the power of cos x plus e to the power of minus cos x. So these two get cancelled. We have integral of 1. Integral of 1 is x from 0 to pi. So 2i is pi minus 0, which is pi, and I is equal to pi by 2. So for the first problem, the answer is pi by 2. It is option 2. Question number 2. So we have to evaluate integration from 0 to 1.5 greatest integer function of x. Remember, greatest integer function of x is defined as the greatest, it is equal to greatest integer not greater than x. It is the greatest integer not greater than x. For example, the value of this is 1. Value of 2.999 is 2. Greatest integer function of 3.1 is 3. Greatest integer function of minus 2.7 is minus 3. So we have to write the greatest integer which does not exceed the given number. For 3.1, the greatest integer which does not exceed 3.1 is 3. For minus 2.7, the greatest integer that does not exceed minus 2.7 is minus 3. If you write minus 2.7 on the number line, this is 0, minus 1, minus 2, minus 3. Minus 2.7 lies here, and we have to write minus 3, not minus 2. So the number we write should not exceed the given number. Given number is here. If you write minus 2 exceeds minus 2.7. So it is wrong. So we have to write down the greatest integer which does not exceed minus 2.7. Then the answer is minus 3. So this is how we define greatest integer function. Now we break this integral into two integrals. One is from 0 to 1 and the other is from 1 to 1.5. Value of the greatest integer function from 0 to 1 is 0. Value of the greatest integer, here the limits are 0 to 1, that means the value of x varies from 0 to 1. As x varies from 0 to 1, the value of the greatest integer function is 0. From 1 to 1.5 it is 1. Therefore the first integral is 0. For 1 the integral is x, so 1 to 1.5, it is 1.5 minus 1, which is same as 0.5. So the answer is 0.5, which is option 1. Question number 3, we have to evaluate the integral of minus 1 to 1, x to the power of 2015 plus x divided by x to the power of 6 plus x to the power of 4 plus x square plus 1. Whenever you have a problem where the limits are minus a to a, see whether the given function is even or odd. Most of the times that function will be an odd function. So let us see whether it is an odd function. Suppose I take this as f of x. It is x to the power of 2015 plus x divided by x to the power of 6 plus x to the power of 4 plus x square plus 1. Let us determine f of minus x. F of minus x is minus x power 2015 plus minus x divided by minus x power 6 plus minus x power 4 plus minus x whole square plus 1. Minus x to the power of 2015, the power is an odd number, therefore it becomes minus x power 2015 minus x divided by x to the power of 6 plus x to the power of 4 plus x square plus 1. Here all the powers are even numbers, therefore we get x to the power of 6 plus x to the power of 4 plus x square plus 1. Now we can take out minus sign, we get minus of x to the power of 2015 plus x divided by x to the power of 6 plus x to the power of 4 plus x square plus 1. Therefore it is minus of f of x. So we have established that f of minus x equal to minus f of x. This shows that f of x is an odd function. Because f is an odd function, integral from minus 1 to 1 of f of x is 0. So the answer is 0, which is option 1. Next question is question number 4. It is integration from minus 10 to plus 10 x times modulus of x to the power of 11. So let us consider this as f of x. Let us determine f of minus x. F of minus x is minus x modulus of minus x power 11. We have to replace x by minus x. Then you get minus x. This becomes minus x power 11. So you can write it as minus x times modulus of x power 11. So it is same as minus f of x. Again we have shown that f of minus x is minus f of x. Therefore f is an odd function. Because f is an odd function, integration from minus 10 to plus 10 of f of x dx is 0. So the final answer is 0 and it is option 1. Again it is option 1. So the correct answer is option 1. Now question number 5. It is given integration from 0 to pi x f of sin x is equal to a times 0 to pi by 2 f of sin x. We have to determine the value of a. Consider the integral 0 to pi f of x sin x. Take it as I. So it is x f of sin x. Now we can replace x by pi minus x. Using one of the properties of definite integrals, this x can be replaced by sum of these two minus x. That means we can replace x by 0 plus pi minus x. We have to sum these two and then write a minus x. So x can be replaced by 0 plus pi minus x. So that means pi minus x. But sine of pi minus x is sine x. Sine of pi minus x is sine x. Now multiplying, we get pi f of sine x minus x f of sine x. Now this integral is nothing but I. So 0 to pi x f of x sin x is I from equation 1. Suppose we call this as equation 1. From that equation, this can be replaced by I. Therefore, I is equal to 0 to pi times f of sin x dx minus I. Shift that I to LHS. Shifting, you get to 2I equal to. So if we shift minus I to this side, we get to 2I equal to 0 to pi times f of sin x. Now observe, sine of pi minus x is sin x. So using a property of definite integrals, this can be written as 2 times 0 to pi by 2 pi f of sin x. Using this property, integral 0 to 2a f of x is equal to 2 times 0 to a f of x, provided f of 2a minus x is equal to f of x. If f satisfies this condition, then 0 to a f of x can be written as 2 times 0 to a f of x. So we are using that property. So that means we have to divide this limit by 2. So here we have pi, so we have to divide this number by 2. We get pi by 2, and we have to write a 2 here. Now these two get cancelled. Therefore we have I is equal to pi times 0 to pi by 2 f of sin x dx. So by comparing with this one, we see that a is pi. Here we have pi, therefore a is equal to pi. So the final answer is pi. The value of a is pi, and it is option 2.
Question number 1. First question, you can take I to the power 2n outside. The remaining part will be I power minus 3, I power minus 1, I to the power 1, I power 3. If you take this picture, this is I power 0, I power 1, I power 2, and this is I power 3. I power 2 is nothing but minus 1. This is nothing but plus 1. This is I, this is minus I. Then I power 4, 5, 6, 7 and so on. It will be cyclic. According to this order, this is I and this is minus I. 1 divided by I is equal to minus I. Easily you can prove by multiplying minus I by minus I. So 1 by I is minus I. This is minus 1 by I, which is equal to plus I. So this will also be I. Now all these things get cancelled. So this will be equal to 0. So for the first question, the answer is A. Now, question number 2. The greatest negative integer. See, minus 3, minus 1. Minus 1 will be the greatest negative integer. Now, greatest negative integer for 1 plus I by 1 minus I whole to the power n. They are asking. But 1 plus I divided by 1 minus I, if you multiply and divide by its conjugate, you will come to know that this is nothing but I. Now the question is simplified as I to the power n. We need to find the greatest negative integer for n, which is possible only when if it is power minus 4, then we get it is equal to 1. Because I power n is equal to 1 implies n must be equal to minus 4 if it is a negative. If it is positive, 4 and multiples of 4, usually 4n you will get it. So in this question, option D is the appropriate answer. Now, question number 3. 1 minus cos theta plus I sin theta, let's take. 1 minus cos theta plus I sin theta. Our intention is to find the inverse of this. But initially let's consider only 1 minus cos theta plus I sin theta. 1 minus cos theta is nothing but twice sin square theta by 2. I into twice sin theta by 2 cos theta by 2. Now take twice sin theta by 2 outside as a common. Now we get sin theta by 2 plus I into cos theta by 2. Now we need to find the inverse of this actually. So for that inverse we need to find only the modulus. That modulus means this is the modulus part. In that inverse the modulus part will be only this. Just you reciprocate this part, you are getting half of 1 by sin theta by 2 is nothing but cosecant theta by 2. So this is the modulus part of z power minus 1. So half cosecant theta by 2 is the appropriate answer. So option C is correct. Question number 4. 1 plus I is the first complex number associated with 2. In what way is it associated? 1 plus I. In what way is it associated with 2? You take the modulus of this, square of this modulus, that is 1 square plus 1 square, which is equal to 2. Similarly, you take the another number, 1 plus 2i, 1 square plus 2 square will be 5. And so on continuously if you do, in the right hand side, we have x plus iy. Its corresponding square magnitude is nothing but x square plus y square. Therefore, x square plus y square will be the appropriate answer. So, B is correct. Now, this is the question number 4. Now, question number 5. If theta equal to pi by 7, then cos phi theta plus I sin phi theta whole to the power 3. Cos phi theta plus I sin phi theta can be written as e to the power I phi theta whole to the power 3. Similarly, the another one, e to the power I 2 theta whole to the power 5 divided by, similarly denominator consists cos 2 theta minus I sin 2 theta, that can be written as e to the power minus 2i theta whole to the power 8 into cos 3 theta plus I sin 3 theta whole power 9 can be written as 3 theta whole to the power 9. Now you focus only the coefficient of theta, that consists numerator, this is 15 and here this is 10 and minus of minus will become plus 16. If it goes to numerator we get minus 27. That if you simplify we get 30, 41 minus 27, that is equal to 14. Now this is nothing but e to the power I 14 theta. The theta value is given here as pi by 7. So e to the power I 14 into pi by 7. 7 cancelled. So we get e to the power I 2 pi. That means cos 2 pi plus I sin 2 pi. Sin 2 pi is equal to 0. Cos 2 pi is 1. Therefore 1 is the answer. So for the fifth question, option B is the correct answer.